Right, when looking at question 6, it's about the hydrogen NMR or proton NMR analysis of ethanol and ethyl ethanoate. I think one of the most important things is what the question doesn't say. And what it doesn't say is draw structural diagrams to help you get the right answer. So that's a really good bit of advice, I reckon. So here is ethanol, C, 2 hydrogens, hydroxyl group, and then 3 more hydrogens. I think it's worth drawing all the atoms and all the bonds. And then for the ethyl ethanoate, well, the O8 tells us that it is an ester. This part here is the ethyl group on the ester. And then we'd need another 3 hydrogens over here. Alright, so now we've got the 2 structures. There's the ethanol, there's the ethyl ethanoate. Alright, let's get in and have a look at this. It says apart from TMS, there are 3 peaks in the low resolution NMR. So 3 peaks says 3 hydrogen environments. When we look at ethanol, there is 1, 2, 3 hydrogen environments. And the ethyl ethanoate, there is 1, 2, 3 hydrogen environments. So that is common to both, which I think is a lot easier to see when we look at both of these. Alright, just going to leave this one for a moment. Look at number 3. One of the peaks is split into 3 fine peaks, a triplet, which suggests we're looking for 2 neighbours. So when we look at this one here, this group here has got 2 neighbouring hydrogens, so it's true for ethanol, and this group of 3 hydrogens here has got 2 neighbours, so we're going to see that is true for both of them. This one's a bit trickier. This one here's a little bit trickier. A peak at 3.7, so that would suggest what we can do is jump into the data book. And when we jump into the data book, we see here for alcohols, move my hand out of the way. So if we've got a primary alcohol or a secondary alcohol, we're expecting something between 3.3 to 4.5, and that value we're looking for, the 3.7, fits nicely into that range there. If we come down and start looking at the sort of shift we would see in the ester, those hydrogens there in the ethyl group in the ester would have a shift of 4.1. Alright, so this data here would relate to ethanol, but not to ethyl ethanoate and not to both. Alright, and when we look at the peak area, 2 to 3 to 3, and we look here, 3, 2, 3, so that is ethyl ethanoate only. The next question is a really pretty pathways question, and it asks you to come up with a pathway telling us how you would turn a sample of ethanol into ethyl ethanoate. So I think we'll start like this and say ethanol, and what we would want to do is have a powerful oxidizing agent, let's say dichromate or potassium dichromate, K2 Cr2O7, and we're also going to want to have some H+, and that would give us our ethanoic acid, and then we'd want to combine the ethanol and the ethanoic acid in the presence of H2SO4 and heat to give us our ethyl ethanoate. Suggest how the product could be isolated from the reaction mixture. Ooh. Technically, fractional distillation is not a part of the course, so it's a bit tricky to answer that one without saying that. Different boiling points. Due to differences in polarity. Therefore, distill. Okay. See you again soon.